So solving linear equations and inequalities, we can do all of these on our calculator. Every single one of these can be done on your calculator. If it says solve an equation, usually with one variable, I could do it on my calculator if I needed to. Well, we shouldn't need to, but, okay. Just reminders then. Equation, mathematical statement that two expressions are equivalent. The solution set of an equation is the value or values that give you the answer. Okay, make it true. A linear equation in one variable can be written in the form ax equals b. A and b are constants. Right? So you've seen lots of them. Here's a couple of examples of linear equations in one variable. Okay, and nonlinear equations. One thing to notice is the variable in the linear equation is not under a radical sign, is not raised to a power other than 1. All right, so if it's a linear equation, we're only going to have x to the first power. All right, so solving linear equations. When we do these, we are trying to get the variable by itself, right? Okay. So the first thing we always have to look at is, can I simplify before I solve? Right. So for this first example we've got here, n minus 2 plus 8n equals 7. Right. Can you do any simplification before you solve? Okay, we've got an n and an 8n on the left-hand side. So our first step here then is going to be combining them. So n plus 8n is 9n minus 2 equals 7. And really our goal is to always get to this form right here. ax plus b equals c, something like that. Right. Because you're familiar with these, you've solved a lot of these because, you know, that's our simplest form of the equations that we've worked with, because they're basically in slope-intercept form. You can think of it that way. Right. All right, so what do I do now? Add 2 to both sides. All right. And divide by 9. So n equals 1. And you should check these. All right? What does it mean to check them? Okay? Make sure it's right. If I take my solution and I put it back in for n and make sure the left side and the right side are the same. Now, one thing I notice is that with that handout you have, there's not always a lot of room, right? Okay, so if you have to write on another sheet of paper to do these, then that's fine, because you can see what I did is I actually, on mine, I moved it over so number 3 is hidden and I'm going to do number 3 down lower. All right, just because there's not enough room there. So if you need more space, write it on a separate sheet of paper and then attach it. That's okay. So if we plug 1 in for n, we'd get 1 minus 2 is negative 1. Put 1 in here for n, we get 8. So 1 plus 8, negative 1 plus 8 is 7. So that would work. But make sure you are checking them. And one way you can check them, like I said, is you can just go back and put it in your calculator. Right? If I take my calculator, and then you could say that your check was with your calculator. Right. So 1 minus 2 plus 8 times 1, and that does equal 7. So it's a true statement. Okay, did it right. Right. But you can just plug it into your home screen of your calculator to check these equations. All right, number 2. Right. So our first step is always simplify, if you can, one side or the other if they need to be simplified first. All right. So in this case, can I do any simplification first? All right, and we're working with your favorite things, right? Fractions. You guys love fractions. So, we've got negative 9/4 and positive 3/2 here, so we got to put those together. So we got to do common denominator stuff. You got to figure out a common denominator. All right, so what's the common denominator with 4 and 2? 4 is, okay? So, if I have 3 over 2, that's the same as what over 4? Okay, 6 over 4. So this is 6 over 4 here. All right. So when I simplify that, the left side here we have negative 2a minus 9 over 4 plus 6 over 4 is 3 over 4 equals negative 1/4 minus 3 over 2a. All right, so change 3 over 2 to 6 over 4. All right, and then combine that with the negative 9/4. All right, so first step, simplify one side or the other. Now we have a variable on both sides. We have a on the left and a on the right. So what should be my next step then? Do what? All right, add 2a to both sides. Why do we want to add 2a to both sides? Okay, we're going to switch sides. All right, and here's the thing is that we always want to get the variables, simplify them first. Okay, and we want to move the 2a because negative 2a is smaller, because negative 2 is smaller than negative 3/2. Okay, why is that important? Michael, why is that important? That's right. We want the coefficient of our variable to be positive. So we're going to add 2a to both sides. And 3/2 plus negative 3/2 plus 2 is what? Negative 3/2 is the same as negative 1/2, right? So 2 minus 1/2 is 1/2a. All right. What's our next step then? We simplified it so we just have one variable in our equation. All right, so now we want to get the constants together. So we're going to get rid of this negative 1/4 and add 1/4 to both sides. All right, so negative 3/4 plus 1/4 is a negative 2/4, which is the same as what? Negative 1/2, right? All right, so let's use our brain instead of having to do everything like it's, you can only do it if you do the equation, right? Okay, so this says negative 1/2 equals 1/2 times something. All right, what's that something going to be? What's going to make this side look like that side? Okay, negative 1. All right, so a equals negative 1. All right. Now, if I did do it though, all right, we know that to get rid of this 1/2, we have to divide, correct? All right, but if it's a fraction, instead of dividing, we are going to multiply by the reciprocal. All right. So when it's a fraction, instead of dividing, we multiply by the reciprocal. All right. Either way, we're going to end up with a equals negative 1/2. All right. Number 3. Wow, this isn't working very good in here for me today. Okay, number 3. I got a bunch of parentheses, right? So if I have parentheses, the first thing I need to do is, okay, get rid of them. So we got 4 minus 16n equals negative 12n minus 8 minus 4. All right, so I got rid of the parentheses. Now what? Okay. Can we simplify on one side or the other, or both, possibly? Can I combine 4 and 16n? Okay, no. Negative 12n minus 8 minus 4. All right? Okay, the 8's and 4. So 4 minus 16n equals negative 12n minus 12. All right, put that 8 and 4, negative 8 and negative 4 together. Now, I have it so that it's simplified on both sides. So look at the two variable terms. Which one is smaller? Okay, Michael, which one's smaller? Negative 16, all right? So we're going to add 16n to both sides. Always do the variable before the constant. Do you have to? Not necessarily. It's just I always want to work with positives if I can. So we get 4 equals 4n minus 12. So we add 12 to both sides. And divide by 4. So n equals 16, equals 4, excuse me. And then I could go to my calculator, type this into my calculator just as it is. Wherever there's an n, I replace it with 4 and check to make sure it's correct. And you want to do that. All right. Okay, you do number 4 on your sheet. Just number 4. Don't do number 5. Just work on number 4. All right. So there are 4 symbols we use to represent inequalities. All right, less than, greater than, less than or equal to, greater than or equal to. So write what each one looks like on your paper. All right, what does the symbol look like? Write it above the words. All right, less than, greater than, less than or equal to, greater than or equal to. What do they look like? Okay. Now, the one thing to remember is, too, also, is that less than or greater than depends on where your variable is. Right? Okay. Because if I had, so here we go, letter A here. This says x is less than or equal to 21. So x is less than or equal to 21. Okay? Because the x is on the left side. Now, since D is on the right side here, it means D is greater than, because the alligator is eating the D. So D is greater than 3. All right, and you fill out C and D. Okay. Letter C, y is less than 1. Letter D, v is less than or equal to 3.14. All right. Graphing inequalities. All right. How many of you remember how to do 1 and 2 here on graphing simple inequalities? All right, go ahead, graph them. All right, so those two should look like that. Graphing compound inequalities. This is how you read this. I know how some of you read it, okay? And I'm probably going to read it differently. I'm going to read this, first of all, and you tell me if you read it like that, all right? X is greater than or equal to negative 4 and less than 2. How many people, when they read it that way? Okay? How many of you read this as negative 4 is less than or equal to X is less than 2? How many people read it that way? Okay. All right, how many people don't read it at all? All right, Sebastian, good. Way to be honest. Always start with the variable, okay? Don't start and read left to right. Start with the variable, okay? This says X is greater than or equal to negative 4. So I'm going to put a closed dot on negative 4. And it says greater than or equal to, so that means I'm going to the right. So I'm just going to start my line going to the right. Not going to continue it, just get a little start to it. Okay, I know it's going that direction. When we have a compound inequality like this, where the variable is written between the two inequality signs, it means and. All right? And. X is less than 2, so at 2 I'm going to put a open dot because it does not include 2. It says less than, that means it's going to left. Oh, good. So I'm going to connect these. All right, with a bold line. Right on the old number line. Okay? So here's the thing. And implies together. All right? Which means I'm going to connect them. Connect the dots. All right. All right, so let's look at number 4. All right. X is less than negative 1. All right, so open dot, negative 1. We know it's going left because it says less than. Or X is greater than or equal to positive 1. Open dot on positive, close dot on positive 1. Oh, that's going to the right. Oh, so those are going opposite directions then. All right. Opposite directions. Okay. All right. So, or implies apart. Okay. Or they go opposite directions. All right. And means coming together, so we connect the dots. Or means apart, which means they're going the opposite ways. Okay? All right. All right, so we know about inequalities. If I'm solving an inequality and I divide by a negative, what do we have to do? Switch the direction of the inequality sign, okay? So there's the one thing you gotta remember. Multiply or divide by a negative, we gotta switch the direction of the inequality sign. All right, so now, are these really any different than the ones we just did with the equal sign? Okay, no, they're not anything different at all. So go ahead, you do 5 and 6, do them. And I'll do them up here while you're doing them. So don't forget, here on number 6, you got to remember to flip the direction of the inequality sign when you multiply or divide by a negative. All right. Now, number 7. All right, so we're going to do this, and then we're going to put our answers on the number line. Okay? So there are two different statements being made here. How many of you think you could do all of that at one time? All right, I see one hand. Great. Okay? So when you're doing these compound inequalities like this, they should come together when you're done. They better, okay? Because it's an and situation. But to solve them, you should pull them apart. So I'm going to do negative 33 is less than or equal to 6k minus 3. And I also need to do 6k minus 3 is less than or equal to 57. You need to solve both of these statements. All right, so don't think that is one single statement. It's actually two of them that you need to solve. All right, so we add 3 to both sides. 6k is greater than or equal to negative 30. And divide by 6. So the one on the left, k, is greater than or equal to negative 5. All right? So we have to solve both of them. All right? Do the one on the right. Add 3 to both sides. 6k is less than or equal to 60. Divide by 6. We get k is less than or equal to 10. All right? So when you're done, and the number line I've given you is not big enough, okay? When you're done then, these should be, because it's an and, these are going to come together. So I put a dot on negative 5, close dot on negative 5, and a close dot on positive 10, which is down here. So I'm going to add that, and then we're going to connect them. All right. So anytime we have a compound inequality like these two at number 7 and 8, when it's written like that, that means it's and those are going to come together when you put those points in there. Okay? They absolutely will. Okay? All right, look at number 9. We're not going to do number 8 right at the moment, unless you're already working on it. Okay? Number 9. Go ahead and do number 9. Okay, that's an or statement, which means that when you're done, they should go the opposite directions. All right, go ahead and do number 9. So you should have x is greater than or equal to 7, so close dot on 7 going to the right. X is less than or equal to negative 5, close dot on negative 5 going to the left. All right, we good? All right, so today then, your